My name's Marian Small, and I had a chance to try this activity out with some students, and I'd like you to try it out and see how it works with yours. What it's built on is division and the notion of remainders. So what will happen is students are asked to type in a particular number. We're suggesting over 50 of counters. The counters magically appear when you press the button that says scatter. And what the kids have to do is pick a number so that when you group these little counters into groups of 3, there's one guy left over. But when you group the very same counters in groups of 4, there's 3 guys left over. What number could you try? What we want them to discover mathematically is that there is a pattern of numbers that work. And when you look at the pattern of numbers that work, it turns out that they are 12 apart. And that has something to do with that 3 and 4 that we use. So they will discover that. But we want to use the tool to make the job easier, less tedious, so that they can focus on the ideas instead of on counting counters. So when I press the scatter button, I say how many I want that they appear. When I press the button to ask for them to be grouped in 3s, it's quickly done by the computer. I can see if there really is one left over or if there's not. Once I have a situation where there is one counter left over, I can then group in 4s. Are there 3 counters left over this time, yes or no? So the kids don't spend all their time just counting counters. They spend most of their time thinking about the relationships and seeing what works. Eventually, they discover that there are answers that work, and those answers are 12 apart. They start thinking about why they are 12 apart, and you as a teacher can extend that. What if these were the numbers instead of those particular numbers, and they're 15 apart or they're 16 apart? What do you think my question was to make that happen?